All right, in class today, we're going to get into everyone's favorite, and that is word problems, particularly inequality word problems. All right, so first we have to start by brainstorming some words that we might write into, and I think we've addressed some of these already, but some words that might indicate some of these inequality symbols. So let's start with the is greater than symbol, the um, alligator mouth eating the left-hand side, as some of you like to say, okay? The is greater than symbol. So think about some words that might indicate the is greater than symbol. Pause the video and see if you can come up with the same ones that I did. All right, so hopefully you came up with is more than. If you saw that in a word problem or heard that, that would be indicating that the one side is more than or greater than the other side. Is over, okay? One value is over the other one. That would be indicating that we would use the greater than symbol. Is heavier than in terms of mass. Is longer than, okay? Is bigger than, and exceed. So yes, we read from left to right. We read from left to right. So if I said n is over 20, I would write n and then the is greater than symbol 20. N is over 20. If I write n exceeds 20, n is bigger than 20. The narwhal is longer than 20 feet. The narwhal is heavier than 20 pounds. Of course it is. It's a narwhal. Okay? etc, etc. All right, so let's brainstorm some words on the next slide for is less than. And yes, you can just use the antonyms of the ones that you did from the previous slide. So is less than, some words or phrases that would indicate is less than. Hopefully you got is smaller than, is under, is lighter than, is shorter than, is below. Come on, bullet. There we go. Or come short of, come shy of. Okay. Does not hit that number or something like that, right? So if I get out my pen once again, hopefully they're working today better than they were the other day. If I say um, the length of L is shorter than 15 yards, that would indicate a less than symbol, is less than symbol, and L is smaller than 15 yards. Okay, moving on. Now, this is where it gets a little tricky, okay, but it also makes the most sense in terms of indicating where we use the inequality symbols, okay? The is greater than or equal to symbol. The is greater than or equal to symbol. So that's the greater than symbol with a line under it, of course, is greater than or equal to. And there's one really, really important one, and I do believe I have referenced it before. Another way of saying that a number is greater than or equal to another number would be to use the phrase at least. At least is another way of saying greater than or equal to. Okay, so if n is at least 10, okay, Nancy's age is at least, she's at least 10 years old. Okay, let me actually write that out. Nancy is at least 10. That would indicate that she could be exactly 10 years old, is at least 10. It could also indicate that she is an age that is older than 10, probably something based on the context of the statement, probably something around 10, 10, 11, 12, 13, 14, 15, whatever, but she is at least 10. We have not put any other constraint on it, so it is greater than 10 or equal to 10. Another way to represent the is greater than or equal to sign would be at a minimum, okay? At a minimum. You need, at a minimum, a 2.5 GPA to remain on the Duke lacrosse team, okay? At a minimum. You could have a 2.5 GPA to remain on the Duke lacrosse team, okay? But you would need to be greater than that. And I just made that up, of course. Don't go Googling something I say. That was just an arbitrary statement I said. At the smallest is another way of saying is greater than or equal to. Can't go under. Cannot go under a particular number, okay? No less than is another way of saying that. And no fewer than. And sometimes people get jammed up on these translations, particularly because they see the less than sign, or they see the less than words, and then they want to write the less than sign. However, it is saying exactly the opposite. It's saying no less than or no fewer than, right? It is saying just by using the no or the not or something like that, it is indicating the greater than or equal to sign. A little tricky, but hopefully we'll get a couple examples that make this a little more um, pertinent. Brainstorming words or phrases that mean the opposite, is less than or equal to. So yes, we can use the antonyms from the previous page. Instead of saying at least, we would say there's an upper limit. At most, you may have at most 5 cookies today. You may have at most 5 cookies today. Okay, that means we could have 5 cookies. We could have 5 cookies if we wanted to. And the number of cookies I'm allowed to consume is less than or equal to 5. 5 is still okay. That's still legal within the constraint. Or I could choose to have 0 cookies and stay healthy. I could say I'm just going to have 1 or 2, that kind of a thing. But I could have 5. So it is at most. 5 is my upper limit. Speaking of that word limit, that's probably another good word. Okay, at a maximum. At a limit, when you're talking about a speed limit sign, the speed limit on Falls of Noose Road is 45 miles per hour. So another way that they could have represented this, and they probably won't, they say n representing your speed must be less than or equal to 45 miles per hour to avoid any legal ramifications of getting pulled over by an officer for excess of speed. Right? So your speed could be 40, right? Could be 41, could be 42. You could be going 35. You probably shouldn't go too slow because then you become an obstacle on the road. But at a limit, you should be going 45 miles per hour at the fastest on Falls of Noose Road. Okay? Can't go over. All right? That kind of says the same thing as a limit. No more than is another way to say this. Okay? Or cannot exceed. Cannot exceed 45 miles per hour. So this, when you're using the less than or equal to sign, is an upper limit on the problem. All right, let's get a couple examples here. So we are going to, just like we did in units, I think it was unit 2, and then unit 4 again, we're going to define a variable. We're going to translate to an equation and then solve that equation and then to try to decipher some meaning. So first thing we have to do when we read about Jacqueline here is define what is the unknown and what does it stand for. Jacqueline needs to wait 3 more years until she is over 16, the age needed to drive a car. What do we know about Jacqueline? So define a variable. I'm going to use J, since that stands for Jacqueline. I'm going to say J is equal to the unknown, which is Jacqueline's age. And you might already logically have an idea of how old Jacqueline is, and I understand that this is pretty elementary, but we have to start somewhere. Jacqueline's age. Okay, and let's translate. Jacqueline needs to wait 3 more years until she is over 16. All right, interesting. So J stands for Jacqueline. Okay, Jacqueline stands for J. 3 more years, that would be more years. 3, so it's going to be J plus 3 to be over the age of 16. Over, which word is that? Well, it's not equal to 16, or it's not at least 16. It's saying definitively over 16. So that's going to be our greater than symbol. Okay, over is the greater than symbol here, and then I'll write 16. So when I add 3 years to Jacqueline's current age, it results in 16. All right, so solve. Hopefully, everyone has either mentally or could figure this out by now what the correct inverse operation was to solve this. You're going to have to subtract the 3 from both sides. Okay, and then we find that J is greater than 13. What does this mean? Let's put it back into context now. Remember, J stood for Jacqueline's age. So that means Jacqueline is over 13. Okay? Do I know that she is 13 and a day? Do I know that she might even be 14 and a half based on what we have understood or what we have derived from the problem? Okay? But I do not know anything other than Jacqueline's age is over 13 years old. Unlike an equation where it says definitively is, this time it's an inequality, right? So what do I know about Jacqueline's age? I know that she is over 13. Not equal to 13, but over 13 years of age. Hopefully that makes a little more sense. Let's go on to another one. If you add 8 more miles per hour to Caroline's bike speed, you exceed the road speed of 30 miles per hour. What do we know about Caroline's speed? Alrighty. So let's define. I'm going to say C is going to be Caroline's speed. You could pick whatever variable you like, of course. Caroline's speed. So far, so good. My pens are working today. And let's translate. If you add 8 more miles per hour to Caroline's speed, so let's go ahead and do that. And it says specifically to add 8 plus Caroline's speed, you exceed. Go back in your notes if you forgot what one that was. Exceed, that means go over the road speed of 30 miles per hour. And this one's very much like the last one, but I think we have to start at some 1-2 buckle my shoe ones to kind of get the ball rolling here. 8 plus C is over 30. So let's go ahead and solve then. Let's go ahead and solve. There should be one step in solving this. And where's the right pen? One step in solving this, and that's subtracting 8 from both sides. I don't have to do any sign flipping. I don't have to do anything interesting here. And what I have found out is C is bigger than, make sure my math is right, 22. Right? If you add 8 more miles per hour to Caroline's speed, you'd exceed the road speed of 30 miles per hour. Now, here's the deal. I'm going to see people write C equals 22. And that's not necessarily solving everything about Caroline's speed because I don't have enough information to know that Caroline is going exactly 22. Based on the words in the problem, it is saying that C must be over 22. Caroline's speed is over 22 miles per hour. And that's pedaling pretty fast on a bike. Oh, maybe she's going downhill or something like that. Okay. What about this one? The $700 Carlos made last summer was at least double what he made this summer. What do we know about the money Carlos made this summer? This summer, not last summer. So we've got a couple summers here. We've got this dude Carlos. He is earning money. Defining our variable. What do we know about the money Carlos made this summer? Well, I actually don't know what he made this summer because that's the variable. So I'll say C, once again, C, is equal to Carlos money this summer. Okay, let's translate. So the 700 made last summer was at least, let's highlight that word at least. I'm just going to underline it. At least. And go back in your notes and figure out, okay, which one logically makes sense for that. 700 at least double what he made this summer. That's referring to Carlos's money. So let's see if we can just work from left to right, translating this. $700 is at least. And hopefully you look back and realize, okay, at least is the greater than or equal to sign. $700 is at the smallest what he made this summer. At the smallest, double what he made this summer, at the very least. So that's greater than or equal to double what he made this summer, excuse me. 2 times C. All right. So $700 is at least double what Carlos made this summer, and I've defined my variable as saying C stands for Carlos's money. Now, we'll go ahead and divide by 2 on both sides, and we'll find that 350 is bigger than or equal to C. So this one's a little interesting because C ended up on the wrong side, or not the wrong side, but the right-hand side. And I'm trying to figure out meaning for C, Carlos's money. So if 350 is bigger than or equal to C, if I read this just from right to left, which no one really does, but if I read this from right to left, I would say C is less than or equal to 350. C is less than or equal to 350. Both of these things have the same meaning mathematically, okay, but one's a little bit easier to interpret when C is the subject of the statement rather than the $350. So let's put meaning to it. If C is less than or equal to $350, that means Carlos made not at least this time, but at most 350 this summer, or has made. I'm not exactly sure what the timeline here is. Carlos has made at least, or sorry, at most $350. So Carlos, you got to get working, get on your grind there, Carlos. Right? You're not quite at your 700 mark that you had last summer. Carlos made at most $350. Let's see if that works. You could, just like any inequality or equation, you plug it back in and see if it works. So if 350 times 2 is smaller than 350 times 2 is $700, and that is smaller than or equal to $700. In that case, it's equal. Okay. Let's see. If Drew lost 3 pounds, he could compete at the lower weight class, which has a limit of 145 pounds. All right, so I'm pretty sure this is talking about wrestling or boxing or something like that. Some sort of combat sport. I don't know who would ever talk about those types of sports. But if Drew lost 3 pounds, he could compete at the lower weight class, which has a limit of 145 pounds. So in those combat sports, you have to make a weight, and you can weigh in for your weight class at exactly whatever the weight class is defined as. Um, and that weight class is defined at a particular number. Hold on just a second. All right, back at it. Slight interruption there. If Drew lost 3 pounds, he could compete at the lower weight class, which has a limit of 145 pounds. So go back. What is a limit? A limit means that you must be less than or equal to whatever that value is. Okay, so define D is equal to Drew's weight. Drew's weight. Okay, and let's translate. If Drew lost 3 pounds, Drew's weight is D. If he subtract 3 pounds from that, he could compete at the lower weight class, which has a limit less than or equal to 145 pounds. Okay, so let's solve. The only thing to solve here is if you just add the 3 to both sides. Okay, so let's go ahead and do that. Plus 3. And we'll solve to find that D is less than or equal to 148 pounds. Meaning, okay, D is less than, well, what did D stand for? D is Drew's weight. Okay, so let's put meaning to this. Drew weighs at most 148 pounds right now. Okay, because if let's say if he was 149 pounds and he lost those 3, then he's 146 and he does not qualify. If he's 148.3 and he lost those 3 pounds, then he's 145.3 and he still does not qualify for that particular weight class. Has a limit less than or equal to. All right, and that should be enough to get you going on your homework. I would recommend, just like we did in Unit 2, getting a highlighter to highlight the key math words. And follow this 3-step process. Define, translate, and solve. And you don't necessarily have to rewrite them in a sentence, but I find that it really does make you think about, does your answer make sense or does your answer not make sense? All right, let me know if you have any questions. Thanks.